All right. Hey, everybody. Welcome to Friday morning of reInvent, huh? Made it this far. All right. I also said I didn't realize we did sessions on Friday morning, but you guys are here. We're excited about that. We're going to talk about some really cool stuff today. My name is Brandon Lindauer. I'm a specialist solutions architect focusing on media and entertainment workloads. We've got some great stuff lined up today. I just want to give you a quick primer, quick heads up. This is a 300-level session. We're not going to throw a whole lot of code at you, but we are going to throw a lot of concepts, a lot of deep concepts, and we're going to go through them really quickly. So the second or third time you watch the replay of this, you'll be good. If there's something that you want to learn a little bit more about, and we just didn't cover it in depth, there are a lot of other sessions that were at reInvent. They get posted online. If you're watching online, hello from the past. So this session is not about a single point solution. It's not about a single service. We're not talking about like open search or recognition in isolation. What we're talking about is building a complete end-to-end system, a platform that allows you to intelligently analyze, understand, and action on large media libraries. So along with my colleague Robert Raver and Loic Barbeau, we're going to cover Bloomberg's vision of the future. And there we go. So we're going to cover Bloomberg's vision of the future. We're going to get deep into some analysis and creation of metadata on this media. We're going to talk about how to ingest and organize petabytes of content. We're going to talk about how to build hybrid search that understands both keywords and meanings. Knowledge graphs, we'll get into a little bit of that. How to use AI agents to orchestrate complex content workflows, create content from that, and then we'll talk a little bit about where Bloomberg's at with this whole thing. So to hop in here, we got a lot to pack in. We'll just hop in. Loic Barbeau from Bloomberg.
Good morning, everyone. My name is Loic Barbeau. I'm the head of media technology for Bloomberg Media. Raise of hand if you've heard of Bloomberg Media. Oh, that's a good amount. Okay. And by the way, thank you for coming here this morning on the last day of the conference. As Brandon mentioned, we have a lot to impact, and there's a lot of knowledge that we want to share with you guys. On my side, I want to share we want to share the visions of Bloomberg and what we're doing in the world of AI and media. Okay, so Bloomberg Media is a global news and business platform aimed at providing data-driven insights to business leaders. Okay. So we analyze the news, we extract all the information from the news, we curate it, and we distribute it in order for those business leaders to make decisions and navigate the complex global economy that exists today. Okay. And we do this by producing different types of content. Text-based content, so that news article, audio content through radio and podcast channels, and also video through our linear distributions of TVs, through mobile, web, and social platforms. And that's for live content and VOD content. Okay. On the video side, that is an area that has the strongest area of engagement right now, and that keeps expanding. The demand is very high. Just to put things in perspective, and that's where we're going to focus on the video side today. To put things in perspective, we have about 60 million of unique viewers every month consuming those videos, with a reach of about 437 million households globally. And we're doing that through 48, and we're doing that by leveraging 48 major streaming platforms. Okay. Here's an example of two of our linear distribution channels. So the first one is Bloomberg TV. Okay. As you can see the screen, it can be quite complicated. This is something that uses a lot of components to not only integrate videos, but integrate the news and provide all of those insights in real time to our users. The second one is Bloomberg Original. Okay. So this is a different type of content. It's long-form content. Can be seen as documentaries, but also highly in-depth analysis of topics that affect the world today. In order to understand our AI journey, I want to talk a little bit about the existing platform that we're dealing with. Okay. So the current media ecosystem that handle workflows like having the ability to ingest content, produce content, manage content, transform content, distribute content, okay, has been designed and implemented at Bloomberg. Okay. And to do it, we use different technology. We use services that are within our own network, but we also use a lot of cloud services. So it's really a hybrid global platform. From a media workflow point of view, okay, we, several years ago, decided to invest a lot of time in order to figure it out what we could do and how we could implement an ecosystem that will provide us the agility that we need to constantly handle changing business objectives and new requirements, but also align our distributions with the ever-changing platforms. And to do this, we created a serverless ecosystem running on AWS, really that has the ability to leverage new components in a fairly easy way, where we can introduce new services. The concept of dynamic workflow is also part of this. So we can really adapt our processing very easily in terms of the amount of content that we are dealing with, also with the change of these media workflows. Okay. In our world, there's also complexity that comes with the many sources of content that we're dealing with. It's not about distributing it, but it's about understanding where we get our content from. In fact, content can be ingested from live TV productions, could be contribution feeds, could be coming from raw content coming from an event, or could also be already content that is stored within one of our repositories. So that's what we consider historical content. There is one thing that we have to implement with every workflow is we have to be fast. Nobody cares about all financial news. We have to be accurate, and we have to be trusted. So the selections of how we actually process our media, we make sure that we address every single one of those requirements in every decision that we make. And that's going to be the same for anything that we're going to be doing with AI. Okay. Okay. Now let's talk about AI. Okay. So we've all used the ChatGPTs of the world, and we've all done some very cool things with it. But when you try to apply those concepts of Gen AI to media, this is where things are a little bit more complicated. In fact, okay, the statement that I made several months ago, I think, was not well understood by even a few of my peers at Bloomberg, but now it is clear that this is actually the only possible and viable way that we can move forward. The future of media AI is archive-driven, not artificially invented. What does that mean? It means that a video of me doing a backflip on stage actually exists. If you search it, you're going to find it. It's not real. It's synthetic content. This is not what we're trying to do as a media organizations. But what we're trying to achieve here is to use all of the content that exists, that we've ingested, that we stored in our platforms, to leverage that, extract the insight from those contents, and assemble it in order to produce a compelling video that match the specification of the distribution target. Okay. So that process is actually complicated, because you have to put in place a platform that is capable of really understanding all of your content, process your content, and deal with it. Our journey started by experimenting, like everybody else. Okay. And we found some good stuff. And when you start looking at some of those capabilities, you're going to see that, well, this is really cool. It feels like magic. You can give a video to an AI model, and from there, you can extract metadata from that media. Who are the people in the videos? What are they talking about? That works well, but in the context of a single video. And as the video gets longer, things don't work. As the video gets more complicated, it loses context, and the generated information may not be accurate. There is a concept that is supposed to address that is RAG. And I'm sure you may have heard of it. And RAG is really the solution to Gen AI to say, hey, when you have a lot of data, you need to index and generate embeddings for that data, store it, and then all of your AI models, workflows, will now leverage that information in order to produce something that is actually coming not from the outside world, but from your data itself. Okay. The problem with that is that when you try to scale this, it becomes extremely complex, as not all content is really created equal. And the type of processing that you need to do on that content really changes based on your workflow, and you need to really re-engineer some of those workflow completely every time you're not going to need to make a change. In fact, in the content that you indexed, may not have the right information in order to achieve an output that you want to do later. So do you have to re-index everything? Well, when you do that for a lot of content, that becomes very expensive, that becomes very complicated. Okay. The other part that became clear to us is that as we're starting to design those media AI-driven workflow, you have to design the workflow, you have to implement the workflow, but you have to test the workflow. And that's something that takes a long time. Okay. By the time you're done testing it, there's a new AI models, there's a new way of implementing an AI-driven pipelines that is much better than what you've done. So how do you deal with that? The last point is, the last problem that we've seen in here as well is that when you implement those complex workflows, you have to make decisions which vendor, which model you're dealing with. And when you see that the technology used by those vendors may not now provide what you need, it's extremely difficult to remove them from those workflows and from your ecosystem if you want to switch them into something else. Okay. So it's complicated. Okay. And what we decide to do is not to move forward in implementing something, but instead, we did an analysis of all of the moving parts that we think needed to be tweaked when a new AI model needed to be introduced, when we had to generate a new type of content. When we needed to extract some information from our content that was not already existing. And by doing so, we identified a couple of areas that are the dial that we need to turn within our platforms every time we need to address one of those changes. Okay. The first one is versioning. We introduce the concept of versionings to models, embeddings, services, workflow, pipelines. What does that mean? Well, it means that when you have a query and a prompt that is getting executed, within those prompts, you can actually trigger specific versions. And you can say, I want to use this version over this one for a model or for an embedding. So there's multi-levels of embeddings that are stored with different versions that can be targeted through different pipelines and workflows. Not only we did that for versions, but we also did the exact same thing for quantifying the level of data that we extract as embeddings and that we generate to the different steps of the workflow. So there are workflows that are considered to be production, and there's workflows that are considered to be non-production within the same ecosystem. So now we can have multiple flavors of a given workflows that is generating production data and generating content and videos, but we have other ones that are not maybe good enough, or they have not done enough testing yet in order to get promoted to really a production output. The fact that they exist together, we can actually really tune those things as part of one platform, and we can easily promote or demote a certain part of a workflow. So it provides a dynamicity and an agilities within the workflows where we can really bring in model, remove model, and tune processing pipeline in a way where we get the total observability on the quality of the output, the performance, and the cost of each step of running those workflows. Okay. The other concept that we put in place, and this one is very, very important, is the ability to deal with multiple databases of metadata and embeddings. The simple way of doing this is you extract your embedding, you store that inside a database, a vector database, and then you basically you use that for all of the workflows. What we end up doing is needed the ability of storing multiple type of embeddings that could be created from an audio embedding model, video frames, using Vision's AI, or even using the transcript of the videos. So they're being stored into multiple repositories, multiple databases. There's different versions because we're using multiple models. So it becomes complicated in terms of the number of places where you actually store the data. We created a concept of a federated search with one search service that has the capabilities of selecting the right database to pull the content. But when you think about deciding which database to use, that can be complicated. So we also have an AI layer there that analyzes the prompt, that analyzes the query that are coming to the search, rewrites the queries, realign those queries to point to the right repositories, to the right database. It also has the ability of really merging all of that, the output together, reprocess it, and returning. So there's now that level of abstractions between all of the embeddings and the version and embeddings and the metadata that can be semantic or even GraphDB, and the inference workflow that are using the data to actually create and generate content. Okay. And I know that statement, that title of the slides may surprise you, but at the end of the day, that was really key for us, is we realized that platforms matters, models don't. And what I'm describing here to you is something that we quantify as our disposable AI strategy. Before you introduce one of the services or one of the models, we really think about what will need to be done when we need to remove it from the ecosystem. When you start thinking that way, the decision you're taking is a little bit different. Okay. Well, that's the concept. Now, I'm going to transition to Rob, who is going to explain to you how we actually achieve those goals.
Cool. Thank you, Loic. Good morning, everyone. My name is Robert Raver. I'm a specialist solutions architect like Brandon, so I have the pleasure of working with customers like Loic to be able to build these solutions and platforms that enable our customers. So I wanted to talk really quick about taking us on a journey, right, from ingest to the end of creating content. And when we look at that, we want to break it down into these 5 buckets. How do we ingest content? How do we analyze it? How do we understand it? And then how do we create? So we're going to walk through this high-level architecture. And you can see this resembles a lot of what Loic was talking about. Loosely coupling together services, making it modular, being able to swap in new models, version, prompts, etc. So on the left is really where we're going to start with ingest. We're going to go through this, touch on it lightly, and show how to get content in. We're then going to look at how to analyze that content. How do we get meaning? How do we extract information out of that? We're then going to look at how to understand it better. And then after that, we're going to look at how to search it, and then also how to create new content. When we're going on this journey, we look at agents in the top right, very similar to people. When agents need to search, they'll search just like you would. They will have the same experience. So let's hop in and talk a little bit about ingest first. When you're thinking of ingest, you want to make sure you account for the different options. How are you going to ingest file-based media, right? How are you going to get that and land that in the cloud? How are you going to take live content, ingest it, and start to analyze it? What archives do you have that you need to bring in and also analyze it? And then if you have third-party feeds or contributions, how do you get that in? Really what we want to look at here, though, is how do you create a funnel? How do you take all of those sources and be able to get it into a central spot that you could trigger workflows from and analyze it? That way, you don't have a bunch of unique snowflake kind of workflows, one-offs that you have to manage, right? You want to be able to make it efficient and have everything be analyzed the same. Once we get to that stage, we're going to talk about analysis a little bit. So when looking at analysis, from that last slide, we get content into S3, and then S3 sends an event saying, hey, I got a new file here, new asset. We're going to look at how to trigger workflows here. And when you think of that, analysis on media has really changed over the past years. If you look at this, there's 3 different types of analysis. There's task-specific models out there, right? These are your models previously, like recognition or others. We have a new way of analyzing media, vision language models, or VLMs. And then we have embedding models. How do we generate embeddings, and what do those mean? If we were looking at task-specific models, these are models that are trained and are looking for a very specific thing. They're looking at generating labels, right? Looking at something that's predefined, like a transcript. If you look at vision language models, those are a little bit more free-form. Those are where I could take an asset, ask a question, right? Describe this to me. Not just tell me if a person is there, but tell me what that person is doing in natural language. And they accept natively video, image, audio, right? When you look at all these modalities, you want to be able to analyze audio, video, image, even documents the same, to be able to create that unified space. And most importantly, these models often require no additional training to be able to do that. So it's zero-shot reasoning, meaning I could take my media, put it in there, ask a question, get an answer back. Then we look at vector embeddings. Vector embeddings, probably my favorite thing right now. What we have here, though, is how do you take an image or video and transform it and understand semantically, or a different way of understanding it, and represent it with numbers. If I create a vector which is a flow of numbers that allows you to compare quickly meaning. So is that just a dog, or is that a dog wearing a bandana on a beach? How do you do that? So when we do that, we'll take things like text, images, videos, and we'll put that into an embedding model that outputs these vectors, which is a bunch of numbers. The numbers yourself, if you look at it, aren't going to tell you much, right? When you put that into the vector space, kind of a three-dimensional space, it starts to create this 3D model of what is closely related or not, right? Is that a Yorkie over there? How close is that to a gorilla, right? And you're starting to measure similarity and meaning. And when you look at that from a multimodality purpose, you can start to look at audio, compare it to images, compare it to video, portions of your video. So the question is, if we have these three different ways of analyzing content that's evolved over the past years, which one do you pick, right? There's a lot of options out there. The short answer is all of them. You use each of them and use what they're best at to be able to create a rich understanding of your content that provides meaning. And so what you do when you start building a media management platform is you're starting to create this unified architecture of bringing all of that together and correlating and relating that to surface insights. So if we're looking at that, and then you take that to AWS services and our partners, here's a couple of the services and models that do that, right? You use things like transcribe, recognition video for labels, or structural breakdown shot scene. You can use Bedrock that hosts the models, our first-party models and our partner models, to do things like produce embeddings using 12 Labs Marengo 3.0, or our new Nova multimodality embedding model, to bring that together, keeping that content in there. So to look at that really quick, just to give you an idea of that, just wanted to kind of walk you through this real quick demo of what that looks like. So if I look at this is a previous session. You might recognize that person, guy maybe in the corner back there. If I start to play that, right, how would you describe that, right? If I asked you what's going on in that video, how would you tell me what's happening? Would you say person, blue, hand? Probably not. You would talk about what's being seen, what's happening, providing that natural language. So if you take that and you look at using a Nova model, this is a quick Jupyter notebook that I ran. This is using our Python Boto 3 SDK, really quick, with Kiro, which, by the way, on running with Opus, a few sentences will produce this for you. Pretty neat nowadays. But this is how it described it. I asked, hey, let's see here. The prompt was, why don't you tell me about the second speaker in the video, right? Describe the second speaker in the video. There was a speaker before Brandon, there was Brandon, speaker after Brandon, very similar to like here. This is what comes back, right? He goes, the second speaker is a man with a beard, still true today, wearing a light blue shirt and blue jeans, right? If you look at the different ways, if you look at an embedding, it's just going to be a bunch of numbers. It's not going to tell you that. But what it is going to tell you is how similar it is to potentially a search term. If you look at labels It's not going to tell you, it's not going to know who the second speaker is. It's not going to understand context, temporal timelines. And that's really what we want to do, right? Is start to use each one of these methods, use what they're good at, combine them, and do it efficiently. So if we were to go back and we look at doing the analysis, we're now going to move to search, right? And so if you kind of look at this middle section, this is really where everything happens, right? It's where you ingest, you analyze, you unify, and then you access it. And so particularly search and agents, right? If I look on the top right over here, if I have a conversational interface that talks to an agent and I ask it questions, it's going to use that. Or if I use a one single turn search, it's still going to use that search API. That way you give the same experience to everyone. Traditionally with search, people would use keywords, right? People might even use file names, right? Like they might get clever and put, underscore IND3331 and expect people to know that that's Brandon talking or myself. Didn't quite work out. So what we're really looking for is how to make that so people can find what they want in seconds and then understand what that is and use it. But search is a funny thing. How I search for something versus how you search for something might be very different. How I describe something that's happening versus you, probably very different. And so search really needs to adapt. Search needs to understand you and what you're asking and not be static. And so if you take that data that we were talking about, that analysis, you break that into 3 categories as well of how to use it. Do I do a keyword search, right? Is that Robert Raver? You notice in that example I gave previously, I said, hey, describe that second speaker. Did it say that was Brandon Lindauer? No, it has no clue who that is. He's not that famous. Just kidding. I only wish I was as famous as you. No, but a keyword, right, if you tag him in it from a custom face perspective, keyword's going to match on that quickly. From a vector search, if you say, hey, find me people talking or presenting or on a stage, it's going to find similarity. You kind of want both, right? So that's why you come in with hybrid search. So if you look at keyword search, traditionally it works off of data stores like OpenSearch. That's going to use an algorithm and look at keywords in index fields. And it's going to look at frequency. It's going to look at closeness. Is it an exact match? Is it a fuzzy match? How often does it happen? To give you that back. If you look at a vector and a vector engine, you're going to be looking at how do you take that, map that space out, and then query it. How similar is it, right? When you're doing a vector query, you're basically taking 2 vectors, those 2 numbers, comparing them and saying how close are they or how far apart are they, right? A Yorkie running downstairs compared to me on a stage, hopefully are pretty far apart, right? And they wouldn't be close. Now, when you look at that and you're finding similar content, what you're really doing is you're saying, here's my vector, right, a search term, a person on stage talking. And you're sending it to this vector space or this index of vectors, and it's going to give you a top K or a top number of results back. Similarity scoring, right? It's going to give you, hey, I have something super close to what you're asking for, or yeah, no, we don't have anything anywhere near that. And typically when we think of it in multimodality models, like our Nova multimodality model, 12 Labs Marengo, some of the open source models out there, it's semantically understanding what it is. But it's important to note that embeddings are specific to the model, and the meaning of those embeddings are specific to that model, meaning it might be trained on semantics, the next one might be trained on my voice. Can I identify my voice from the heuristics? So then we get into actually searching, right? We want to search this data. So I have a couple search terms here, right? Brian on a stage with 2 other people versus Robert talking about search techniques. How would you weight those, right? How would you determine I'm on stage, Brian's on stage, or how do you know that I'm talking versus more than one person on stage, right? If you look at modalities, if you're going to say, is there 3 people on stage? You're going to visually look and see, right? You're not going to listen to see if you could hear that. But if you want to hear me speaking about something, you're going to look at my transcript. You're going to look at what I'm saying, right? If I'm waving my hands up here, you have no clue if I'm talking about search or Yorkies. By the way, I like the Yorkies. I have a couple of them if you haven't guessed yet. So what you want to do is create a hybrid, right? The answer is, how do I use search and break that down into search intent and be able to do that? And so OpenSearch has a way of doing that built in, using an algorithm for ranking. You can also do that yourself at an application layer, really, and I encourage you to test with both. We're going to look at doing that at an application layer, or a little middle layer, right? If I say keyword, Robert Raver, I'm going to weight the keyword much higher than a vector for inspiring movies. And so what you want to do is you want to dynamically do that. And so if we look at our architecture in a little bit more detail, we have a search input box here, right? On the left, we have kind of thumbs up, thumbs down to give feedback to help over time fine-tune this. And what we're going to do is we're going to put a search term in here, and it's going to send it to API Gateway. And Lambda's going to answer it, and then it's going to take that and say, here's the search term. What is the intent of that search term? What are they really asking for? And so it's going to go to an LLM, and it's going to say, hey, here's my search query. How should I look at this? At the same time, it's going to create embeddings for the data stores or the embeddings you have. And then it's going to be able to query those, bring those back, and then really be able to give you a final answer. So if we were to look at that, here's another little Jupyter notebook I have, and I did something similar. So up here, we have a prompt. It's a prompt that was just created. I'm not saying this is the best prompt in the world for it, but going back to Louis' point, right, this is what you want to be able to version, improve on, iterate on, measure. And it says, hey, I have these data stores, right? Analyze the search term, bring back a weight, and tell me what I should pay attention to. So if you go back to 3 people on stage with 2 other people, which doesn't really make sense now I look at it, but what it's actually looking at is down below, you'll see the LLM weight analysis. And you see visual is a 0.9, right? It understands that I'm going to visually look to understand how many people are on the stage. And you know what? There might be specific people, so I'm going to give it some weight. But from an audio perspective, that's not going to really help me. So I want to ensure that I'm searching the right areas to be able to do that. Now, if you go back to that other search term we had, Robert talking about search, you can see how that changes. People goes up. It's looking for a person named Robert. Its transcript goes way up, right? It knows that I'm looking for something about me talking. And then audio in this case is audio background, right? Somebody making a loud noise, car going off, whatever, right? It's like, okay, well, no, we actually really want to understand somebody talking. So once we get there, we really want to understand what we have, right? So if you do that, you get a bunch of results back, but that doesn't necessarily mean you get true contextual meaning as to what the search results are, right? If it gives me a bunch of results back, say 100 videos of me talking, how do I make sense of that? How do I understand how those are related? And so we look at knowledge graphs then. So we use these purpose-built data stores to be able to then relate content. And there's a few different ways to, you can use graphs. Ultimately, what a graph is, though, is you're taking these two nodes, right? A person, an asset, and you're creating these relationships. And there's different ways you could do that, right? You could do that temporally, like what's happening over time, or identity, domain, et cetera. And really what we're going to do is split that. And then we're going to use that graph, in this case Neptune Analytics, to be able to do searches and be able to create meaning. And so when we look at that same analysis, that same data we produced earlier, we're putting it into the graph as well as OpenSearch, and we're searching it in different ways, right? These are different data store types, different ways of searching to get meaning out of data. But you could use those same embeddings, and now you can start to correlate, right? So if you look at this, you start to build this graph, right? There's a person that appears in an asset. An asset is created from an asset. There's a story that happens in a place. And when you start to do this, you create understanding. If I have 100 assets, but let's say I actually created a new asset from 4 other assets, and then I created even more assets from that because I'm sending it to YouTube or TikTok, you get to understand, right? Like, oh, by the way, those 7 assets are actually really the same thing. You just create a new assets, right? If I have search results and 7 of them are the same thing, I probably want to identify that and make it so you know it and be able to say, hey, you know what, these are really the same asset or derived from each other. Here's the unique ones. And so what we do is we take the data of that analysis, we populate that knowledge graph at the same time as our OpenSearch, and then we query it the same way. And so when you're looking at that, when you populate a graph and it's relationship-based, you're taking that and we're doing something called creating a virtual entity. A lot of people will search for content and look at what's in the content and expect to say like, hey, here's 100 assets and it has this person in it, that person in it. But in your mind, do you think that way? Or do you really want to say like, hey, you know what, I'm interested in Rob as a person. I want to actually then go to Rob and understand what information I have about Rob, what assets he appeared in, what was maybe recreated. And so you start to take that same data and create virtual entities in this graph, which are those nodes, and start linking it together. And you create this entity that starts to understand my voice, starts to understand maybe my face, other characteristics, and you build those all together. And so when you look at that, if we go back here and look at it, we created this sample graph they want to look at, right? And it's fictitious information, looking at 2 summits that might have happened, right? Tech summits here. Maybe one in the spring, and maybe one in the fall. But you start to understand, like, what were the keynotes saying, right? What were the sessions saying? What was the stories being told? And so when you start to look at this, instead of just seeing a single bit of information, a single asset, I could start to understand what topics were talked about, right? What assets relate to those topics? What was the connections here? Who was saying that? And when you start to look at that, you get to the point where you start to be able to understand what's in your assets, how is that connected, and how things change over time or how are they related. So in this instance, using that graph, I can not only say Rob and Brandon and Loic, I have them in my assets, and they might have been talking, but I could say who's returned speakers between my events. What is the topic evolution? How does that talk track change? In 2024, they're talking about RAG. In 2025, maybe Graph RAG. And then you can start to see how stories evolve. And once you start to understand how these stories are evolving, what do you have? You can start to use that to create new content, to create new stories, right? We want to spend less time searching, less time doing this manual work of trying to understand what we have, and have that context surface to you quickly, and to let you use it how you want, right? To create quality content, stories, search. With that, I'm going to pass it back to Brandon. Brandon? Over there.
Thanks, Rob. So, it's a quick. That was a quick but deep overview in a lot of the technologies behind searching, right? But in reality, it's not just search. Nobody wants search. You don't want to pay for search. You want to pay somebody to search. You want to find, and that's the technology that lets you find what you need, lets you correlate things across multiple entities, events, things like that. But finding data is only part of the story. If you can find content, great, you found it. But if you can action on what you found, that is where the real value comes in. So Rob and I sat down with Loic and we said, hey, let's talk about creating content, right? What does that look like for you? There's a lot of things that you could do. With that metadata that we generated, with the different ways to search and find it, there's a lot of things we can do. There's a couple things that I'll highlight, and we're going to dive into one of these. But when you automatically create content from this, think about if you have thousands and thousands of hours, the petabytes of data that Bloomberg has in their archive. Traditionally, you have somebody sitting there that has to just go through all that manually. If you're able to find that and you're able to find it automatically, suddenly the things that you can do, putting stories together, creating new stories, is amazing. We're going to dive a little bit into the expanded reach, though, right? So Louis gave us this example. Imagine you have a 30-minute interview with a prominent actor, right? Great, you got to sit down with them. You get this great interview, all of this content. 2 minutes of it makes it to air, right? Traditionally, what would happen is, well, that 2 minutes made it to air. Take the rest of that 30-minute interview, throw it in the archive. Maybe one day we'll be able to use it. Now, in recent years, there's lots of platforms, right? There's lots of ways to expand reach. You can post it to all kinds of social media on the Facegram or the InstaSnap or whatever they are, whatever the kids are doing these days, right? And they all have different ways that you reach people. But that requires a little bit of curation of that content, and there's actually a lot of labor associated with that. So if we want to expand this reach, through YouTube, TikTok, Instagram, things like that, we're going to look at this automated process. It's going to start with a user request, right? Your natural language query, a producer goes in there and says, hey, we have this 30-minute interview. Cut this down and make it available to these platforms. Make it available to our standard channels. Using things like agents, using parallel execution, assembling those things together, and even allowing humans to review it if you want, will give you this fully automated pipeline for content creation. So I'm sure agents is a word you haven't heard at reInvent this year, right? That and AI. So this is what we imagine it looks like, right? If you say, I want to do an automated content assembly and creation. So your user comes in and says, hey, make this 30-minute interview available to our various social platforms. Right? Well, YouTube, it's great. We can post the full thing there, right? 2 minutes of it already made it to air. But we have platforms that want a 10-second version. They want a 30-second version, a 2-minute version. We may have multiple 10-second cuts that we want to do that reach different audiences or that get across different topics, right? And that's a lot of stuff there. So we start with an analysis, right? Summarizing and understanding the metadata. That's a lot of what Robert went over, right? Understanding all of this stuff, searching, understanding what the user's intent is when they go through that. At the same time, as you understand those and you understand what you need to find, what you need to search for, you can have a selection process going, a selection agent that's going to go through and it's going to find the different portions of this video that are useful in 10 seconds, in 30 seconds. This is your editor, right? This is the editor sitting there going, this is useful, this is the part that I want to use. The assembly. So also part of the editor, but this does the work of putting these things together, right? So it's one thing to say, cool, I have a 5-second chunk here that I want to show. I have a 30-second clip that I want. Or I have these two things that I want to put together as a 30-second clip. I might have different angles, right? If we did an interview with this actor and we had 2 cameras shooting them, you're going to ingest those as 2 different files. They're going to be indexed separately. But your entities, your your search and everything that Robert just covered is going to be able to say, yeah, I'm correlating these 2 clips, these 2 portions as the same thing. And you can have a selection agent and an assembly agent look at that and go, you know what, this angle is better right here, this angle is better there. Based on parameters, input, all kinds of things that you can give it. Puts it together, and then you take that output and you run it through and you hand it to another agent and you go, make sure this meets our standards. Make sure that we're not making this actor look bad. Make sure that we are not saying anything we shouldn't say. Make sure we're not violating our content guardrails or, not changing what's in here. I mean, I've worked in video for a long time. You can very much take a clip of somebody out of context. As Luis said at the very beginning, trust is key for Bloomberg. It needs to be accurate, and they need the public to trust them. So having a review agent say, let's make sure that everything's good before we push this out. And in that area, you can also put in a process for a human in the loop. Hey, we want a person to look at these before everything. We want a person to look at it and get back a score from the agent that says, hey, we're flagging this, or these all look good to us based on these scores, right? All these things are possible. And lastly, push it out. You can do this completely automated, starting with take this interview, make it available. And you can have the agent push it out onto all your portals. Now, something like that, you don't always have to use an agent, right? Let's not use AI where an if statement will work. But there are certain situations where you'd say, hey, let me use an LLM to decide if this should even go to YouTube, or if this should go to TikTok, or if these channels are better. Provide that feedback to the humans in the loop. So as we get into that content selection, right, your content selection can actually be multiple agents. You can break this out and have all kinds of things going in parallel. Find me the segments of that video. They can coordinate as needed. You can sync them together. You can find the clips. The assembly agent may communicate back and say, hey, I've got 25 seconds and my target is 30 seconds. Can you find me some fill? I need some B-roll that's related to this, right? You've got all those graph relations. Cool, let's find some images, some cutaways, some video, audio, something that is related to everything else we have going on. Have those agents communicate one another and automatically have this iterative process where they're collaborating. And again, you can always insert human in the loop there. And one of the coolest parts about this is because all of this is going on between these agents, because all of this is happening in AWS with Agent Core, you can take the output from each of those. You can save it with complete lineage. So you can say which angles were used in this. Why were they used, right? What was the score, the model score that chose this? Which platforms were targeted with this cut down? You can get all that information and you have that full provenance of why did we do this the way we did, and understand what the model is doing and continue to improve and continue to tweak. Because again, there's no final one way to do this. There's always room for improvement. Your multi-platform assembly, right? I mentioned different platforms. You've got 9x16, you've got 16x9, you've got 1-to-1, right? You've got things with text overlay. Sometimes when you take a wide shot and you verticalize it, you need to follow the action, right? Sometimes it is a wide shot and you need to bring it down and throw a blur or something in the background so you have the top and bottom that aren't just black. There's different methodologies and different ways to do verticalization or different platform targeting, and you can use LLMs for that. You can use things to decide what should be framed where. You can say what will look better. Should we do a cutaway here? But ultimately, it's about creating what's right for the right platform. So you're not just doing one cut down. You're not just doing a 30-second cut down. You're doing a 30-second cut down and versions for multiple platforms. So, like I said, it starts with a user request. You can do the orchestration with your agents, execute a lot of this in parallel, assemble those results. You can get humans in there. This improves your speed, your volume, your consistency, your traceability, right? The fact that you can now reach more audiences on more platforms faster than ever before, and you can do so in an automated or mostly automated fashion, is incredible. So, Rob showed this earlier in the presentation. We started with ingest. We go to analyze this data. We search it, we understand it, and we action on it with creating content. So we've walked you through with all this, and the cool thing is, that really opens up new revenue streams. And because you can build this on AWS, you can do this in a well-architected manner. It can be built and deployed, highly available, highly resilient, secure and scalable with insights, controls, and monitoring. So, Loic, I'm going to bring you back up here. He's going to explain to you a little bit more about what Bloomberg is doing with all of that we've gone through.
Thank you. Okay, well, thank you to Rob and Brendan to have very well described how we're doing certain things, and also the media workflows that will be leveraging this new technology. But I want to take a step back to reiterate the goals here. The goal of doing this, now that you understand the complexity that we're dealing with, is really about having the ability to create a platform that will be able to handle all of the new business objectives, requirement changes, but also to handle all of the evolutions happening within AI. This is something that is complex. It's complicated. There's a lot of moving parts. It's not possible to re-engineer the whole thing tomorrow when something better is happening. So this is really the foundations of all of the work that we're doing here. Yes, we're going to be able to do all of that, and we're going to be able to change it. Yeah. This platform is also going to unlock a couple of things for us and optimize how we're doing, how do we manage and create content today. Number one, it should allow us to drastically reduce the time to market by improving discovery, management, and distribution of content. Okay. The second thing is to unlock new distribution targets. It's complicated to create new format to target a platform, or to do it well. Okay? And sometimes you have to really manage your workflow using least common denominators and push content that may not be the best for that platforms, but you still have a presence on those platforms. Well, using this, we will be able to create content that really fit those platforms and that can provide better monetizations on those platforms. Reduce cost, absolutely. Okay. Everything that we've been discussing so far is done by human. We're not replacing all the humans, but we're really helping them in not spending time on things they shouldn't be doing. Okay. And I kept the best for last. Okay. There is one thing that we're going to be able to do with this platform that is not possible today. It was said in the infrastructure keynote yesterday that 90% of unstructured data is video. If it's unstructured, it is not well understood. Okay. With this technology, we will be able to really analyze and generate insights from 13 petabytes of existing media that is growing at the speed of 3,000 hours per day. It's not possible for humans to analyze all of that. So we will be able to analyze real-time news, correlate that with everything that exists within our repositories, and create a new type of story. Or be able to tell the stories in a much better way than we can do today. Yeah. Yeah. I would like to thank you, AWS, to have joined us in this journey. When I went to them and explained the concept, and there was a concept, they didn't shut the door on me. Okay? But what they did was, well, you know, what you're trying to achieve is something that we cannot do today. But if we work together and we use the AWS technology and we shape it in a way that it's aligned with your visions, we will get somewhere. And this is exactly what we're doing here. Okay, so thank you. And hope to see you soon with the evolutions of what we're going to be creating here.
Folks, thank you again. Thanks for being here Friday morning, early. You guys are rock stars. There's some more resources right here if you guys want to check out some of the learning. If there was anything in this that you want to dive deep in, the reInvent sessions will be posted soon. You can level up your skills with Skill Builder, so do that. And we will be hanging out here. If you need anything, giving out free high fives, reminding you what to give us on that survey. So thank you, everybody.